Okay, so let's pick back up here. I'm looking at embedded applications. Although microcontrollers are the preferred choice for many embedded systems, sometimes a microcontroller is inadequate for the task. For this reason, in recent years, many manufacturers of general purpose microprocessors, such as Intel Freescale Semiconductor, which was formerly Motorola, and AMD Advanced Micro Devices, have targeted their microprocessor for the high end of the embedded market. Intel and AMD push their x86 processors for both the embedded and the desktop PC markets. In the early 1900s, Apple Computer began using the PowerPC microprocessors 604, 603, 620, etc., in place of the 680 XO for the Macintosh. The PowerPC microprocessor is a joint venture between IBM and Motorola and was targeted for the high end of the embedded market as well as the PC market. I think it should be noted here that when a company targets a general purpose microprocessor for the embedded market, it optimizes the processor used for the embedded systems. For this reason, these processors are often called high end embedded processors. Another chip widely used in the high end embedded system design was the ARM or ARM microprocessor. Very often the terms embedded processor and microcontroller were used interchangeably. One of the most critical needs of an embedded system is to decrease power consumption in space. Well, why is that? Well, because so many of these things operate off of batteries. Okay, rarely do you see a microcontroller application that isn't being used off of a battery, typically a rechargeable battery. So you want to conserve the energy. It's not something that is generally going to be plugged into the wall. And the space requirements then are, what you would see normally in the example of the remote control or your phone. You're talking about a very small piece of real estate that you're trying to get the device into. So this can be achieved by integrating more functions than into the CPU portion of the microcontroller. All the embedded processors based on the x86 and the PowerPC 6XX have low power consumption in addition to some forms of I/O, COM ports, and ROM on a single chip. In high performance embedded processors, the trend was to integrate more and more functions into the CPU chip and let the designer then decide which features to use. This trend is invading PC system design as well. Normally, in designing the PC motherboard, you need a CPU plus a chipset containing the I/O, the cache controller, flash ROM containing the BIOS, and finally, a secondary cache of memory. New designs are emerging in industry. For example, many companies use a chip that contains the entire CPU and all of the supporting logic and memory, except for DRAM. In other words, we have an entire computer that can be built on a single chip. Well, this text was written almost 10 years ago, so you can see today how much that has improved. Currently, because of Linux, DOS, and Windows standardization, many embedded systems use the x86 PCs, and of course, we have transcended that. In many cases, using the x86 PC for the high embedded application not only saved money, but it also shortened the development time because a vast library of software already existed for Linux, DOS, and Windows platforms. The fact that Windows and Linux are now widely used and a well understood platform means that developing a Windows based or Linux based embedded product reduced the cost and shortened the development time considerably. So in the cases where you can shorten the development time by using something that's already out there, we can get to market a lot faster and reduce the cost of the device. In choosing a microcontroller, at the time of this writing, then there were five major 8-bit controllers. Well, controllers now are up to the 32 and 64-bit. At that time, Freescale Semiconductor, again formerly Motorola, the 68HC08 and HC11, uh, Amtel's AVR, Zilog Z8, and PIC from Microchip Technology. Again, the microchip technology, the PIC, is the one that we're going to concentrate on in this class. Each of the above microcontrollers has a unique instruction set and register set. Therefore, they are not compatible with each other. And the idea behind that is, to try to get you to buy and use their chipsets rather than using something that might be compatible with somebody else. Programs written for one will not run on the others. There are also 16-bit and 32-bit microcontrollers made by various chip makers. With these different microcontrollers, what criteria do designers consider in choosing one? Well, three criteria in choosing microcontrollers are whether they meet the computing needs of the task at hand efficiently and cost effectively, whether there is an availability of software and hardware development tools such as compilers, assemblers, debuggers, and emulators, and whether or not they are widely available and reliable as far as sources for the microcontroller. When looking at the computing power of something like the old 486 or even the old 8086, in many applications, the space used, the power consumed, and the price per unit are much more critical considerations than the computing power. The applications most often require some I/O operations to read signals, turn on and off certain bits. So next we'll take a look at microcontrollers used in an embedded processor.